Hey, good morning, everybody. I hope you guys are all ready to get to work. It's 6:20 where I am today. Hopefully this comes a little bit better than it did yesterday. I was working a lot last night on the microphone and writing. I don't have a, a laptop. I have a desktop because I'm an old man. But I do have a thing to write on it, so we're gonna try that today. What I want to go over today is probably not the whole thing, but there is on the website, there's a sheet and it's called Guided Notes, Solving Systems of Equations by Graphing. This will just be a kind of like one final review. I know we've gone over most of this. I anticipated this to be a good place for us to start with this online learning thing because it's something you guys should all be fairly familiar with. We've gone through graphing and things like that. So just a couple quick key vocabulary things. It says a system of equations is a set of blank or more equations with the same blank. Okay, so it's a system of two or more equations. Okay, we're just focusing on two, but just know that there's whole branches of math called like linear algebra and stuff like that, or if you're working in 3 dimensions with x, y, and z, where you can have more variables. So more variables means more equations. So the way to think about it is this: if you have one equation, you can solve for one variable, 2 equations, 2 variables, 3 equations, 3 variables. So right now we're just focused on 2 variables, 2 equations, and they're all going to be linear. Right now that doesn't mean much to you guys, but especially I know a few of you guys have been looking through the testing material and stuff like that you may or may not have to take when we ever go back to school. Who knows? But a big part of that is what's linear and what's nonlinear, and what's nonlinear is what we will be covering in our next unit. So anyway, it's 2 or more equations with the same variables. I know a lot of you guys want to write solutions there, but it's variables. Okay, it's the same. It's in this case x and y, or a and b, and that's important for us because we can only solve 2 equations with the same variables. If they have different variables, then there's no relation between the 2 of them. Okay. So the solution to a system of equations is a set of values for the variables that satisfies, okay? You could put answers if you want, that is a solution to, but it satisfies is typically what we're going to say. So in other words, the x and the y will be true for both of them. It'll satisfy both of the equations simultaneously, okay? The blank of 2 graphed lines is the blank to the system of equations, the intersection, right? The intersection to the 2 lines, the intersection where the 2 lines cross over. So what we're going to be doing, same thing we have been doing, well, this represents all the solutions to equation A, and this represents all the solutions to equation B, right? All these xy coordinates on the way down, and all these xy coordinates on the way up. Well, they have this one in common right here, so it's the only thing that makes them true. So again, we have 2 equations, and we have 2 variables, x and y, and we said this is the answer. So the intersection of the 2 graph lines is the solution. All right. Again, now that should be new to you guys, okay? To solve both equations so these are steps for graphing. You want to solve both equations for y, okay? In other words, put the equation in slope intercept form, right? That's the best way we determined to graph things, right? And that's the same form we have in work now, y equals mx plus b, right? So in other words, if they give you something in, I know we talked about standard form, which was what, ax plus by is equal to c. You can graph. We talked about how to graph it with the intercepts. It's just typically more work than it's probably worth. So you want to go ahead and move the ax over to the other side and then divide by b, so you have y by itself. That makes it nice and easier to graph. Now, also because, I don't know why I'm erasing this, also because you guys know a little bit more, if things are in a different form, then graphing might not be the right answer, right? If everything's in standard form, something like elimination or substitution might be better. You know, you guys are old enough to, you're going to figure out the best strategy. So again, we're introducing these 3 different strategies: graphing, substitution, and elimination, and you're going to have to choose the best method for any given system that you're, well, given, sorry. Okay, using the blank and blank, graph both lines on the same coordinate plane. Well, again, what are we going to use? The y-intercept. Oh, Jesus. Y-intercept, right? That's going to be our starting point. And you should know this by now, but that's B, right? And your slope, right? Right, that's M. That's your rise and your run, right? That's your change in Y over your change in X. We've only been talking about that for, I don't know, 6 months now, right? So you're going to use your y-intercept and your slope to graph both lines in the same coordinate plane. You can also make a table full of values. It's really up to you. The reason I tell you guys is when things are not linear, it's not going to be quite this simple. So we'll talk about different ways to do that, I guess, when we get to it, though, okay? It says find the blank if it occurs. We want to find the intersection. Right? This point is the solution. Okay? This point, or we could say coordinate, okay, is the solution to the system. In other words, you need both. The whole point of doing this is we're solving for two variables. So you need X and you need Y. You should be expressing your answer as a coordinate, okay? You guys should all know that by now, okay? All right, so let's get down to business, okay? Here, again, knowing what you guys know now, you might want to use substitution. You know, y is equal to negative x minus 1. You plug that right in there for y, and you can solve it that way. Really up to you. The sheet is just trying to challenge you and give you things that are not in slope-intercept form. Again, assuming you know no other ways, and yes, you're going to put the first one into slope-intercept form and do it from there. Knowing what you guys know, though, substitution might be a better route for this particular problem. Okay, but again, let's be good little zombies and do what we're asked. Okay, 3x plus y is equal to 9. That's the one you want to rewrite, and let's go ahead and rewrite it. So we have 3x plus y is equal to 9. We're going to subtract 3x from both sides. Now, if you write it this way, it's not wrong. You just have to remember that your slope is negative 3 and your y-intercept is 9. For that reason, and just because, you know, we're pretty good at this, right? We're junior algebra students, right? We know what we're doing, right? Let's write it in the appropriate form. Let's write negative 3x plus 9, and let's leave this weird bar thing here because, I don't know, negative 3x plus 9, okay? So, using the slope and y-intercept, graph both lines on the coordinate plane, okay? So let's start with this one. This is 9, and this is negative 3. Despite, I don't know how to get this thing out of the way. Can I just move it? So whenever I switch things, oh my god. Oh, that's much better. Fantastic. And everything's gone. All right. And it's gone. So negative 3x minus 9. It's always the first thing I write. So if you, listen, I know you guys are much more technologically savvy than I am, okay? But again, let's, if you guys have any suggestions, please help an old man out, would you? Okay, so again, where are we starting from? We're starting from our y-intercept, which is 9. And we've got a slope of negative 3. Now remember, the slope of negative 3, right, as a fraction is negative 3 over 1. So first of all, this line is negative. It should be going down. We're going to go down 1, 2, 3 boxes over 1, 1, 2, 3 boxes over 1, 1, 2, 3 boxes over 1. Oh, this graph paper, for some reason you guys lose your mind. There is a line here, right? The negative 1 doesn't fit because they put the numbers there, okay? So you have to remember there is a line here. For some reason, whenever there's stuff like that, you guys lose your mind. So there's 1 right here, no line, 2, 3, and over 1. 1, 2, 3, and over 1. Okay, so yeah, so again, if you want to kind of draw a line, I'm afraid to draw a line. I'm afraid if I draw a line there that it will just mess up everything. So let's give it a try. I'm going to assume I'm right, and it did. Okay, good, fantastic. Never mind. Okay, all right, so I'm going to do my best to connect. Can I use a line, or is it going to freak out if I try to draw a line on here? It is. Great, fantastic. Okay. There's the line. It goes through. all those points right there, okay? Again, if you had missed this one, it should be off. You shouldn't be able to draw a line through it, okay? And one of the things I always told you guys is a good practice is that we're going to label these when we're done so we know which one is which, but let's draw the other one first. The other one is starting at -1 and has a slope of negative. Remember, there's a 1 here that we don't write. This is -1x, okay? And there's the thing again. Okay, so again, where are we starting from? We're starting from -1, and we got a slope of -1. Okay, so we're starting from -1, which is right here. I know there's 1, 0, -1. Okay, and we're going -1 is -1 over 1. So we're going down 1 over 1. So down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Just keep following and following and following. And you can see that they do intersect right here. Okay, so let's draw a line without trying to mess up this graph. Probably gonna mess it up anyway. Good, and I know one of you guys is gonna tell me that I need to put little arrows on the ends of my lines. You put little arrows on the ends of your lines, okay? I'm afraid I'm gonna mess up this graph if I do that, okay? Let's see, am I right? Yeah, probably. It should be. Remember, this is just one little window. These really keep going on forever and ever and ever, okay? Let's make sure we label them. This one was y is equal to -3x plus 9, right? And this one over here was y is equal to -x minus 1. Good? And again, what's your solution? 5, -6. 1, 2, 3, 4, 5, -1, -2, -3, -4, -5, 6. So what is that? Your answer is 5, -6. Okay, that's x and that's y. So that is your answer. Okay, in other words, if I plug, this should satisfy both equations. So if I plug in 5 and -6, well, 3 times 5 is 15, 15 plus a -6, so 15 minus 6 is 9. Good? And if I plug in 5 and -6, -5 minus 1 is -6. So it does make both of these true. Okay, so if you ever want to go with a check, you can plug it back in. I would show you, but I don't have any room. I don't have any room. Okay, but again, you want to plug in for x, plug in for y up in these equations, and it should make them true. Okay, let's do. I want to do maybe one more, and then I want to get to there's a word problem on here. All right, yeah, let's take a look. You guys should be able to do this one. Yeah, no, there's one little extra thing in here we're gonna have to do. All right, yeah, let's do number 2, and then we'll do that word problem now at the bottom. Okay. All right, so which equation do we need to rewrite? This second one, right? We do the second one because it's not in slope-intercept form. So this is -x plus 2y is equal to -4. Now here's where you need to be careful because we're going to move this x, but in the last problem, y only had a coefficient of 1. Here, y has a coefficient of 2, so we're going to have to divide by that 2. So there's going to be an extra little ripple in this one. That's usually how math problems go, right? They get harder as we go further and further. All right, so -x plus 2y is equal to -4. So the first thing, let's add x to both sides. So we got 2y is equal to x minus 4. Okay. Good. Now, when we divide by 2, remember we have to divide this whole thing. Think distributive property. This 2 has to go to everything, right? So what are we going to get? We're going to get y is equal to x over 2 minus 2, right? 4 divided by 2 is 2. Be careful. This is, again, dividing by 2 is the same thing as, oh, I remember there's an invisible 1 here that we don't write, right? So it's 1/2 x minus 2. Okay, it's actually a little bit easier for people typically when there is a number there. So 1 divided by 2 is 1/2. So this is y is equal to 1/2 x minus 2. Okay, so we're starting from -2. And again, since your slope is 1/2, that's up 1 over 2. So up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Okay. If you guys want, you can continue this pattern. You can go kind of down 1 over 2 if you want. The reason you're allowed to do that is your slope is positive 1/2, right? So this was positive, up is the positive direction, and to the right is the positive direction. But if you think down is the negative and back is the negative, and a negative divided by negative is actually also a positive. So, I mean, long story short, just follow the pattern, guys. But there is a reason. There's a math. Whenever we do math, there's always got to be a mathematical reason for things, and that's why. Okay. So there we go. We're going through our graph. Okay. Our second one is y is equal to negative 2x plus 3. So y is equal to negative 2x plus 3. So we are starting from, hold on, put the dot over here. I knocked it on righty thing. All right, see, I'll put it over here this time. All right, we're going to start at 3, right? We're going to start at 3, and we have a slope of negative 2. So negative 2 over 1 means we're going down 2 over 1, okay? So again, where we're starting from 3, down 2 over 1, 1, 2 over 1. There's our answer, down 2 over 1, down 2 over 1, down 2 over 1. Again, if we want to, we could actually go up and back. Again, that's a positive divided by a negative. So positive divided by a negative is still a negative. Up 2, back 1, up 2, back 1, and that's all we're going to fit. We are going to not attach a file or record video. We're going to draw a line, and we're going to go straight through this thing and kind of adjust that a little bit. Like that. Okay. Let us go ahead and let us label our answers. This is our equations y. I didn't remember this time. Y is equal to negative 2x plus 3. And this is y is equal to 1/2 x minus 2. You can label it by the original equation, by the way. You can label this if you really want to. Okay. But this is 2, negative 1. Okay. So 2, negative 1 is the point that makes both of them true. Good. So again, if I plug in 2 for x, I should get out negative 1 for y. Negative 2 times 2 is negative 4 plus 3. So negative 4 plus 3, negative 1. If I plug in negative 2 plus 2 times negative 1 is also negative 2, negative 2, negative 2, negative 4. Okay, so quick check. And we're good. Okay. All right, I just want to go over this one word problem, and you guys are free to finish any and all of these. We'll be starting something a little bit different on Monday. They get a little more challenging as you go through, so kind of start from the beginning and see how you guys can do. Also, if you guys can't print them, do the best you can. You can draw them. Listen, if old man Matt Wenz figured out how to write on a computer, you guys should be able to do the same, right? You guys are techno-savvy kids. I'm sure there's an app or something, right? You guys figure it out. Okay? All right, so suppose you and your friends form a band. We're getting the band back together, man. You want to record a demo. Studio A rents for $100 plus $50 per hour. Okay, so we have a flat fee of $100, a rate of $100 per hour. Okay, again, don't forget, it's been a while. This is a flat rate, and this is two things, right? This is dollars per hour. Again, that word per tells you it's a rate, okay? And Studio B rents for $50 plus 70, so Studio B has $75 per hour. So that's your rate, and that's your flat fee. So Studio A, all right, so let's write an equation. Y is equal to, well, what was your rate, right? So it's mx plus b, right? Y, mx plus b, right? So y and x are going to stay y and x. M is your rate, and b is your flat fee, right? Because it's your rate because it's multiplied times x. So that's going to be $50 times the number of hours, right? So 1 hour, 2 hour, 3 hour, 4 hour, plus $100 in a flat fee. Okay, maybe you got to pay for the producer or something like that, pay for the engineer. Okay, and the second one is $75 an hour, but a lower flat fee. Okay, so again, what's your advantage here? Well, if you're only going in for a short amount of time, this has a smaller fee, but this is less per hour. So eventually, this is going to be your better choice. So it really depends on how much time you're spending in the studio. All right, dropping huge beats or something, whatever you kids do. Okay, so again, so this one we're starting from 100, right? And we're going up by 50. So my slope is 50 over 1. I know a couple of you guys were doing some test review and you were having like a little bit, the slope of this is, they've modified this graph, right? They gave you, it's got a scale. So every one box up represents 25. They do this because if you had a slope of 50, it would go almost straight up. It would be impossible to read. So we're going up 50. So that's up 50 and over 1, right? 100, 25, 50. So up another 50, 2 hours. Up 50. So this appears to be a slope of 2, but remember, it is not. This is a slope of 50. Okay, so they scaled your graph, so just for usability, just to make it, oh my God, what? How do I undo that? I don't know what I think I just went to the matrix. They scaled your graph for simplicity's sake. I want to draw a line. I want to draw, all right. They've scaled your graph for simplicity's sake, to make it legible, to make it readable, okay? All right. Good, and my second one, we're starting at, over here, we're starting at 50 and we're going up by $75 an hour. So 25, 50, 75, 25, 50, 75. So again, this appears to have a slope of 3, 25, 50, 75. And again, it's not a slope of 3, it's a slope of 75, right? 75 over 1. Right, but it's just to make it easier to do. All right, let's try this again. Not totally mess up the graph. It's giving me a little crosshair. No. All right, there we go. Good. So let's go ahead and let's label these things, right? Label them the way we're supposed to. This first one was y. Y is equal to 50x plus 100. Okay, and this other one over here was y is equal to 75x plus 50. Okay, what's your solution? Your solution is right here. 2 hours is going to cost you $200. 2 hours, $200. So again, if we go into the Studio A, 50 times 2 is 100, plus 100 is 200. If we go into Studio B, 75 times 2 is 150, plus 50 is 200. Okay, explain what the system means in terms of renting a studio. Okay, sometimes the answer is not exactly this point. So what does that point represent? That point represents where the studios cost the same amount of money. Okay, what does it mean in terms of renting a studio? So what it means is, sorry, I'll move this up a little bit. If you are renting for less than 2 hours, okay? Well, less than 2 hours, you definitely want to choose Studio B, right? Because it is less, okay? Once you go past 2 hours, that's when you want to go to Studio A, right? So if you notice, you kind of look, this line is less, this line is less, this line is less, this line is less, switch, now this line is less, right? Now, I don't know about you guys, if they're equally good quality studios, you want to pay less money, right? You're a starving artist and musician, okay? You can buy a better, I don't know, microphone or something like that. Maybe you can buy me a better microphone, okay? So if you're renting for less than 2 hours, choose Studio B, right? Studio B. For more than 2 hours, choose Studio A, okay? And if you're going for exactly 2 hours, it doesn't matter because you're going to pay $200 either way, okay? So we'll probably go over some more things like this, some more, you know, word problems and things like that. I just want to give you guys a rough idea. I really right now just need you guys to make sure you got this skill down so we can kind of proceed. So again, there's a whole bunch more problems on here, okay? If you want to do them on a separate sheet of paper, that's fine. Do them however you feel. Like I said, a couple of them you're going to have to rearrange. But most importantly, if you, first of all, hope you've listened this long. If you have questions, please send them. I will gladly answer them and send them back to you. Okay. But anyway, I hope you guys are all safe. Have a great weekend. It's 6:45 in the morning. I am going to have another cup of coffee. I'll see you guys later. Thank you.